Good morning, everyone. Welcome to this new episode of Biofilm Minutes. Today we will discuss about cooling towers, how they work, what is their role, and how the microbial processes are analyzing this system. Cooling towers are very simple machines that are used for cooling water efficiently with a low energy cost. The role of the cooling towers is extremely important. Therefore, given their size and function, it is necessary to monitor them constantly to avoid the demanding intervention that require plant shutdown. The figure shows the operation of a cooling tower. The processing water in the tower tank is in contact with external air and cools the heat exchanger. Here, the water absorbs heat and still needs to be cooled. It enters the upper part of the tower, where the temperature decreases through the evaporation process. Warm water is sprayed from the top of the tower into a surface. Atmospheric air interacts with the water and the fan blows air up and out of the tower to increase cooling. Evaporative cooling releases heat from the system and produces an aerosol that is released into the environment through openings in the tower. A part of the water is recovered and the cycle starts again. In the cooling tower system, there are the ideal conditions for microbial growth. There are large surfaces, low water flow velocity, warm temperatures that promote bacterial proliferation. Furthermore, the evaporative cooling process increases the concentration of organic and inorganic matter in water, supplying a lot of food to bacteria. Additionally, construction materials in the cooling tower may provide a good substrate for bacterial settlement and proliferation. The most relevant microorganisms that affect the cooling towers are typically bacteria, which can live free in the water but represent only 10% of the total contamination in the system. In fact, 19% of them live adherent to the surface in contact with the liquid, and this community is usually known as biofilm. To find out more about biofilm, you can consult the link indicated here and also reported in the video description. The formation of biofilm causes many threats to the cooling towers. First of all, its ability to act as a reservoir of pathogens. The most common pathogens, such as Legionella or Pseudomonas, can persist and multiply in this environment. Due to water flow or chemical treatment or other factors, these microorganisms contaminate the water and can easily spread with aerosol and travel even for kilometers. The most commonly used methods for microbiological analysis in cooling towers involve liquid sampling and surface sampling. Both approaches include laboratory analysis with culture techniques, flow cytometry, and microscope observation. To sample the surface, coupons can be immersed in water, usually in a racked position in a bypass. Then, coupons are periodically retrieved and analyzed using different techniques. However, these are expensive processes that take a long time and can greatly underestimate the real microbiological contamination. In this context, halving technology, highly sensitive and specific for biofilm, represent an advantageous solution for monitoring bacterial growth in cooling towers, analyzing the heat online and real time, reducing the time and costs necessary to carry out the monitoring activity. To control microbiological proliferation in cooling towers, chemical and physical treatments can be applied, separately or together. The most commonly adopted approach is the dosage of biocides such as chlorine or ozone that are the most popular oxidizing biocides used in a cooling tower. Also, isothiazoline is used for microbial control in a number of industrial water treatments. Among physical methods, UV irradiation is one of the most widely applied techniques to treat relatively clean water where it is effective and rather fast. Another physical treatment that has received some attention is the electronic pulse generation that have the function of damaging the cell membrane of bacteria, causing their death. In conclusion, the control of bacterial proliferation in cooling towers starting from the early stage of growth is of the uttermost importance, both for public safety and for the functionality of the system. Monitoring bacterial growth on surfaces in real time, having sensors allowed to prevent biofilm-related issues, including Legionella contamination and microbiological-induced corrosion. At the same time, this technology makes possible to verify the efficacy of sanitation treatments. For other information, you can visit our website at this link, where you can also view our application cases regarding cooling towers. For any information, you can contact us at the email address shown here. Thank you for your attention and see you in the next video.